Good morning to all of you. In the previous session, we have seen one example where we have computed 8-point DFT using DIT-FFT algorithm. So today we'll see one more example where we'll apply both the algorithms, that is DIT-FFT and DIF-FFT, for the computation of DFT using FFT. Okay. So here the example is specified with x of n comprising 4 points. So that means we need to compute here 4-point DFT. Okay, and it has to be computed, that means x of k, which is nothing but the DFT sequence. It is to be computed by using both DIT-FFT and DIF-FFT algorithms. Okay, so initially we'll try to draw the structure for DIT-FFT algorithm, right? So as it is a 4-point DFT, so we need to draw these 4 lines here, right? Correct. So decimation, in case of decimation in type, the input sequence will not be applied as x of 0 1 2 3, right? So the reverse of double 0 is 0, so first input sample is 0. Next the reverse of 1, that is 0 1, is 1 0, so it will be x of 2 here, right? Next the reverse of 1 0 is 0 1, so it will be x of 1, and double 1 is 1 1. So here the sample applied is x of 3. So it is decimation in time. While output will be in sequence, that is x of 0, x of 1, x of 2, x of 3. Okay. So input are decimated, that is x of 0, x of 2, x of 1 and x of 3. So you can write down the value of these samples. So x of 0 is 0, x of 2, so this is basically 0, n is equals to 0, n is equals to 1, n is equals to 2, n is equals to 3. Similar samples are there, right? So x of 2 is 2, right? X of 1 is 1, and x of 3 is 3, okay, as per the given sequence. So next we have to draw the structure here, that is butterfly structure here, for computation of these DFTs, right? Okay, similarly in stage 1 you are computing 2-point DFT. In stage 2, just a minute. Okay, in stage 2 you are computing 4-point DFT. Okay, so here we can write down the Tweedle factors, or which can also referred as phase factor. So in 4-point DFT, here you have W40. Here also it is W40, and wherever there is Tweedle factor, -1 will be in multiplication. So here -1, -1, and in this case the Tweedle factor are W40 and W41. Okay, so before proceeding we should identify the values of this Tweedle factor initially. Okay, so here I'll try to identify the values of Tweedle factor. Okay, so for computation of 4-point DFT using DIT FFT and DIF FFT, we need following Twiddle or phase factor. Okay, so first one is W40. Basically it is W and K, which is nothing e to the power minus j 2 pi k by n, right? So W40, it will be simply e to the power 0, so it will be 1. Okay, so W40 is 1, and W41 is equals to e to the power minus j 2 pi by 4 will be there, so it will be simply e to the power minus j pi by 2, so it can be written as cos pi by 2 minus j sine pi by 2. So this W41 will be cos pi by 2 is 0 and sine pi by 2 is 1, so it will be simply minus j. Okay, so you can write down these values of twiddle factor here. So W40 is 1, as well as W40 here 1, here it is 1, and W41 is minus j. Now let's try to compute the values of output at every stage, right? So see here, this 0 is coming as it is in this case, right, at this point. So this 0 will be as it is, plus this 2 multiplied by 1 is coming at this point. Okay, so this 2 plus 0 will be 2 here. Here again 0 is coming from this point, and this 2 multiplied by 1 multiplied by minus 1, so it will be minus 2 plus 0, so it will be minus 2, and in this case. So these outputs of stage 1 will be applied as input to stage 2, right? But before that we will compute the outputs of stage 1. Okay, so this 1 is coming as it is here, so 1 plus this 3 multiplied by 1, so 3 plus 1 will be 4 in this case. Okay, so this 1 here coming as it is, added with 3 multiplied by 1 multiplied by minus 1, so minus 3 plus 1 will be minus 2. Okay, so we got these outputs of stage 1, that is 2 minus 2 4 minus 2, right? Next, these outputs will be applied as input in stage 2, so this 2 is coming here as it is, right? So it will get added with this another input at this point, which is coming from this point, so 4 multiplied by 1, so 4 plus 2 will be 6, so x of 0 will be 6, right? At this point you will get output 6. Next, here again this minus 2 is coming as it is, so minus 2 is getting added with this minus 2 minus j, so multiplication will be 2j, right? So here addition will be minus 2 plus 2j will be there. Okay, so minus 2 plus 2j, or you can write j2. Okay, so similarly here at this point, this 4 multiplied by 1 multiplied by minus 1, so it will be minus 4. Okay, so minus 4, and from this point this 2 is coming, so minus 4 plus 2. Okay, so this plus 2 and this minus 4, so it will be minus 2, right? And similarly at this point this minus 2 is coming here, right? So minus 2 plus this minus 2 minus j minus 1, so it will be minus 2j again. Okay, so minus 2j minus 2, so here you will get minus 2 minus j2. Okay, so what outputs we have computed here? So this is nothing but our x of k as per this DITFFT algorithm. Okay, so x of 0 is 6, x of 1 is minus 2 plus j2, right? Then x of 2 is minus 2, and x of 3 is minus 2 minus j2. Now let's try to identify the DFT by using DIFFT algorithm. Okay, so here we have obtained it from obtain it by using DITFFT. Now we'll try to obtain it by DIFFT algorithm. Okay. So in case of DIFFT algorithm, again these 4 lines will be there. Input will be applied in sequence x of 0, x of 1, x of 2 and x of 3. Okay, while output is decimated. Here output was in sequence and input was decimated. Okay, so 0, 2, 1, 3. So here it will be x of 0, x of 2, x of 1 and x of 3. Okay, so the outputs are decimated here, right? So decimation in frequency is there. So inputs are 1, sorry, x of 0 is 0, x of 1 is 1, x of 2 is 2 and x of 3 is 3 as per the given sequence. 0, 1, 2, 3 were written here. Okay. 0, 1, 2, 3. So in DIFFT, so this stage 2 structure will be drawn at stage 1 and stage 1 structure will be drawn at stage 2, right? So initially this structure will be there in stage 1. Okay, and in stage 2 the stage 1 structure will be there. Right. So here again another difference is that on dropping lines obviously there will be -1 in multiplication. Okay, so initially these twiddle factors were multiplied in input, right? But here the twiddle factors will be multiplied in outputs. Okay, so here it will be W40 and here it will be W41, right? Similarly here you have W40, there's also W40. So W40 value is 1 as we already computed it. Okay, here we have computed W401 and W41 is -J. So W41 is -J, right? So now you can compute these outputs here. So here 0 is coming as it is at this point. Okay, another input coming at this point is this 2, right? So the output at this point will be 2 plus 0, right? Here again this 1 is coming, then from this point this 3 is coming, 3 plus 1 will be 4 at this point, right? Again this 0 is coming at this point, right? And this -2 will come, 2 multiplied by -1, -2. Okay, -2 plus 0 it will be -2, right? Again this 1 here it will be 1 first input and another input, 3 multiplied by -1, so -3 plus 1, again -2 will be there. Now here this input 2 will be coming as it is, right? So this 2 and here from this point 4 is coming, right? So 4 will get 4 plus 2 will be 6, so x of 0 is 6 at this point. Okay, you will get 6 output, right? So this 4 here again this 2 is coming as it is, right? So 2 and this 4 multiplied by -1, so it will be -4 multiplied by this 1. Okay, finally, so at this point what you will get, you will get initially 2 minus 4. Okay, So 2 minus 4 will be minus 2 at this point, right? It will get multiplied with 1, so it will be minus 2. Okay. Similarly, at this point, this minus 2 multiplied by 1 will be minus 2, and another input here is minus 2 minus j, so it will be minus 2 minus 2 multiplied by minus j will be plus 2j, and here minus 2, so it will be minus 2 plus j2 will be there, right? So here the output will be minus 2 plus j2 or 2j, whatever it is. Okay, so another output, that is the last one that we have to calculate, it is minus 2 multiplied by 1, that is minus 2 is coming here, right? So minus 2, and this minus 2 minus j minus 1, so it will be minus j2, so minus 2 minus j2 will be there multiplied by 1 again, so it will be minus 2 minus j2 will be there, minus j2. Okay, so these are the outputs, required outputs or required DFT, right? So x of 0 is 6, then x of 1 is minus 2 plus j2, x of 2 is minus 2, and x of 3 is minus 2 minus j2. Okay, you will find this is same as the previous output. 6 is there, right? Minus 2 plus j2, minus 2 plus j2, minus 2 is there, minus 2 minus j2, minus 2 minus j2. Okay, so this is how you can compute the DFT, okay, by using DIT-FFT and DIF-FFT algorithms, right? So in next session we'll see one more problem where we'll compute 8-point DFT by using DIF-FFT algorithm. Okay, we already seen 8-point DFT by using DIT-FFT algorithm. We also seen in today's session 4-point DFT using DIT-FFT and DIF-FFT algorithm. So in next session we'll discuss 8-point DFT using DIF-FFT algorithm. So thank you for joining this session.